Hello, everybody. My name is Jignesh Shah. I'm a senior product manager at Amazon RDS. Today, we are going to talk about open source databases and how to run them on AWS. Typical first question is, why use open source databases? Open source databases have a lot of advantages. They are simple and cost effective. Because the source codes are openly available, which means when you are using them, you are able to kind of quickly go through on how it's actually implemented and how it actually works. It has great support from the community, which means when you search for it on Google, you find answers very quickly. If you still cannot find your answers, you can typically go to an open source community forum and ask questions, and you'll get a response back quicker. There is great support from a lot of other vendors who also provide services around them. The biggest benefit is you are no longer tied to a particular kind of database, which means you can actually take your data and go move to another vendor if required without any limitations. So let's talk about open source databases. Broadly speaking, there are two kinds. The relational databases, which support SQL, and the non-relational databases of the kind like a document database or a key value store. In the relational database, the most popular ones are MySQL and Postgres and MariaDB. And in the non-relational database, you can think of like MongoDB, Redis, or Memcached, which actually caters to a different set of applications. Let's look at the relational databases. MySQL is one of the most popular databases out there. Its popularity is primarily due to the ease of use and the performance that it provides to a database system. One of the guiding principles early on MySQL was like a user should be able to do everything within 15 minutes, install the database and start using it. And also with the popularity came the broad support of clients, which means you can practically have an application written in any language that can work with MySQL. It also actually grew with a lot of features, which like DB providing the ACID compliancy, and that really helped make MySQL pretty popular. And at the same time, it gives you the capabilities that makes it usable in enterprises with the security features, like it does support database at rest table spaces with the DB encryption. MariaDB is also part of the same MySQL family. It was founded by the same founders as MySQL. The idea of MariaDB was to make it more community-oriented with no single company controlling it. With the foundation style of operations, it started adding a lot new features into a slightly more expanded scope, like say OLAP use cases, with wide variety of storage engines. And also it tries to cater to ease migrations from other databases to MariaDB. Postgres was originally started in an academic world. It started as a database that students used and learned and started developing new features as part of their projects. It grew from academia into enterprises because of its robustness and the rich set of features that it provided. With the advance of MVCC, it actually grew popularity in a highly concurrent deployments because it would allow them to do more concurrent users at the same time. And plus, with its rich optimizer plans, it became popular to use it for data warehousing also. It also supports a lot of different languages, which means you can actually do sorting in any language that you prefer. It is highly reliable with its strong compliance, ACID compliance philosophy, and it's probably one of the most standards compliance databases out there. It is also closer to a lot of commercial databases. We do see that in cases of conversions, people oftentimes pick Postgres over other open source databases because it has more closeness to the features that are provided by commercial databases. Let's now look at open source databases on AWS. AWS provides database services on relational databases as well as non-relational database service. On the relational side, we have Amazon RDS, which is the relational database service, and also Amazon Aurora, which is an optimized service to give you enterprise features on top of the compatibility of an open source database. On the relational side, we have DynamoDB, Elastic Cache, and Neptune in each of the areas like the document store, cache, and a graph database. Joining all of them together is database migration service, which would allow you to kind of move your data from one type of database to another, or even from on-premise database to a database in AWS, or vice versa. In today's topic, we will be focusing more on the relational database aspects of the service, primarily on RDS and a little bit on Aurora. Let's first talk about why would you want to use a managed database service or when to use a self-managed database service on EC2. So traditionally, you can do this. You can deploy an instance on EC2, deploy your own database on it, and manage it on your own. Some of the things, some of the advantages that you get with that is you can deploy any software, any version you want. You can have any extensions, custom extensions also deployed, and you have full control over your deployment. You also take ownership of all the security patches that you need to apply at your own schedule, and you get full control on the life cycle of it. On the managed database service side, it's slightly different. You get an endpoint, and the management would be done by the managed service provider. And so Amazon RDS as well as Amazon Aurora falls in this category of managed database service. If you look from a broad perspective, deploying it on EC2 gives you control, but you take the onus of security, management, patches on your own. On the other side, on a managed database offering, you get automation, but do not have access to the host itself, and you will only be able to use tested extensions. So from a wide variety perspective, you have control and automation at the two ends of the spectrums, but oftentimes what you find is once you have figured out your deployment methodology, automation is really what you want to do to kind of ease your, meet your business needs. With automation, also in the managed database offering, security patches and everything will be provided by the managed database provider. In case of RDS and Aurora, we tend towards more of the automations for the providing of the automation side of the features that we do in a managed database offering. What does RDS really provide? RDS provides you three main capabilities. It helps you to administer databases. It helps you to make them highly available and highly scalable. And it does everything very quickly in a secured fashion. It helps you essentially to save cost and time with minimal effort. If you look at the broad spectrum of the engine supported, a lot of activities that you would do would be common from a viewpoint of a customer. Amazon RDS also makes that common operations very easy for each of the popular engines that it supports in a way that is consistent across all these database engines. The three popular engines that we support on RDS are MySQL, MariaDB, and Postgres. We support various major versions. A typical major version is supported for at least 3 years. A typical minor version is supported for at least 1 year. As the life cycles of this major version progresses, we also help you with major version upgrades. Like in case of Postgres, we help you with the one-point click to upgrade from 9.5 to 9.6, or from 9.6 to Postgres version 10. In case of Amazon Aurora has two compatibilities with one with MySQL, which is provided with 5.6 or 5.7 version, and Amazon Aurora with Postgres compatibility is compatible with Postgres 9.6. We'll also be releasing Amazon Aurora with Postgres compatibility 10 soon. Let's look a little bit deeper into the offerings of MySQL on RDS. We support all the major versions, the popular major versions of MySQL. We support InnoDB and MyISM as the storage engines for MySQL. With the new version 5.7, we now also have JSON support, query optimizer improvements, spatial improvements, and also improved parallel replication. We'll be coming out with version 10 soon. In case of MariaDB, we support the latest 10.2, 10.1, and 10 version. It supports the same instance types, which are T2, M2, M2, and R4 series of instances in most regions, and at the same pricing as MySQL. We also have a free tier that you can do for all the open source community engines, which is T2 Micro. In comparing against RDS MySQL, in case of MariaDB, we support the extra DB and the ARIA storage engines only. We also support the MariaDB specific features like thread pooling and global transaction IDs. In the latest version 10.2 of MariaDB, it now also supports windowing functions with common table expressions. It supports special indexes to speed up your special queries, and also now supports a lot of new JSON functions. In case of Postgres, we now support Postgres 10 along with the older 9.6 and 9.5, 9.4 version out there. On top of the core Postgres distribution, we also support 50+ Postgres extensions. A lot of this extension provides capabilities like the spatial extension PostGIS. A lot of extensions also provide maintenance capabilities like PG Repack, which allows you to kind of clean up your old sizes of your table space without taking a full table lock. The extensions really help you to take use of a lot of new features on top of standard Postgres. In the latest version that we support in Postgres in RDS, we now also support native partitioning syntax support, which means now no longer you have to manage partitions for your table without on your own. Basically, now there is a SQL syntax wherein you can actually create new partitions for your tables very quickly. It also supports enhanced parallelisms in queries, which means it is now able to use more than one CPUs for your single query. It now supports multiple column statistics, which means your queries could take advantages of different statistics in your columns and do the correlation between them. And it now supports inbuilt library for internationalization, which means an OS patch will not impact your sorting order anymore. There are improvements in the pgstat activity, which gives you improved reporting in Postgres. It now has about like 126 wait events that is supported in Postgres 10. And then one of the new features that will soon be supporting for Postgres 10 is inbuilt logical replication, which would allow you to pick and choose which tables to replicate to another Postgres 10 instance soon. Now, let's look at some of the features that Amazon RDS provides on top of the functionality of open source databases. The first thing we'll start that every database deployment needs is backup and restore. In the case of Amazon RDS, we allow you to select from no backup, which is 0-day automated backup, all the way up to 35-day backup strategy, which means you basically say enable backup up to 35 days, and you have an option to pick a window when the backup is taken. Once you do that, at that time, within that time window that you have selected, every day a backup will be initiated and completed. And after the number of days of retention that you have, which could be all the way up to 35 days, those backups will be then automatically deleted, which means you no longer have to manually remember to delete them all. If you want to kind of preserve those backups for a longer duration, you could then copy that automated backup into a manual backup and basically preserve the backups for a longer duration, like years if you want. If you use the highly available deployments, which we'll talk about later, in those scenarios, the backups are actually taken from a standby instance, which means there is no performance impact during the backup on your primary. Along with the backup, we also support point-in-time restores. In order to do that, what we do is we also back up all your transaction logs between your automated backups and store them in S3. The ability that we give you with point-in-time restore is you can pick a time between your two automated backups, and the database will be actually rolled forwarded to that time, which means giving you that database recovery at that exact timestamp that you selected. This is great for cases like if somebody dropped a table at say 10:21, you can restore your database to 10:20 and get back the table just prior to the accidental delete or drop. Point-in-time recovery is actually very important from a point of view of giving end user an ability to restore the database to a known sane state. Let's talk about some of the other common tasks that people like about RDS. Given you start small for your deployments of database, as your workload increase, you will want to increase the resources that your database can use. We do provide simple ways to increase your instance size. You could go from 1 vCPU, 1 gig of RAM instance, all the way up to 64 vCPU and 488 gig of RAM. The flexibility allows you to size your database depending on your needs. It could be seasonal, which means like say at the end of the month when you expect a lot of users coming to query on your database, you could increase your size at that point. And once the peak goes away, you can even scale it down back and save some cost on the resources. On the same note, you can even increase the storage that is used by your database. We use EBS elastic volumes, which means you can now actually scale faster with no downtime during your storage scaling operation. On RDS, you can go all the way up to 16 terabytes of storage for your open source instances. The next thing we want to talk about is availability. Databases are generally expected to be highly available. A failure can happen due to a disk failing or hardware failing, a network card dropping packets, and there could be multiple reasons. RDS provides you with a one-click availability option called multi-AC. What it does, it creates an identical standby instance for you, replicates the storage at the other end, and it happens in a different availability zone, and now sets it up for automatic failover. So the way it works is, say for example, you're running in AZ1, If that instance dies, then an external observer will detect the failure, go to the standby instance, make it the new primary, which could be on availability zone 2, and then reset your old primary as the new secondary, and now you're back in that same game. So if a failure happens again, the process will repeat again. This helps you to kind of capture or do automatic remediation for a quick hardware failure or a quick network failure, and allow it to be remediated automatically. Oftentimes, the failure detection is the key, and the DNS IPs will be updated, and you will see the failover completing under a minute or closely around a minute. The important thing is all this happens without human intervention, which means it is automatically failed over and it continues working. Applications typically just see connections dropping, and once you reconnect, it starts going to the secondary and starts operating like nothing happened. Another way typical databases work, especially the open source database work, is they support replication for scale out strategies. The way replication scale out works is you have a primary instance. You will now create replicas of that, which are following the primary instance, but they can actually do read queries on them. This allows you to kind of utilize the secondary instances for scaling out your reads. We support read replicas on all 3 open source community engines, MySQL, Postgres, MariaDB. It helps you to kind of reduce the load on your primary instance, and you scaling out by scaling out your reads to as many instances as you want. We support currently up to 5 read replicas for MySQL, Postgres, and MariaDB. The other advantage that you have with this read replicas is you could actually even deploy these read replicas in different regions, which means you could actually have your read queries closer to your applications in different regions. We do give you the ability to promote a read replica to become a master, which means you can also use this strategy as a DR story, especially across regions where multi-AZ will not be available. Multi-AZ feature typically is only within a single region. So the way you will see a setup that people use often is they use a multi-AZ within the same region with a cross-region read replica and use that for DR purpose. In case of the whole region going down, you can promote your cross-region read replica and make it to be the new master and continue from that point onwards. One thing to keep in mind is all read replicas in Amazon RDS are asynchronous, which means they do not put additional load for your writes that are happening on your primary instance. Read replicas are great for scaling out, especially if you have 70% reads or 80% and higher reads happening on your database instances. Now let's talk about Amazon Aurora. Amazon Aurora comes with MySQL and Postgres compatibility. Amazon Aurora basically has performance changes in the open source engines in order to give you higher performance than the standard community engines. It also has new features or additional features on top of the community features. And these features are designed for enterprise deployments. One of the most important feature is the Aurora storage. We'll talk about Aurora storage in the next slide. It also has features which will provide you with fast database cloning. Aurora storage is a copy and write storage, which allows us to kind of give you lightweight database clones at any given point of time and spin up a copy and give a clone at that point. We also are supporting zero downtime patching. It will be coming soon for the Postgres compatibility. And it has more tighter integration with the rest of the AWS ecosystem, like giving you ability to invoke Lambda functions and many more. In the next slide, let's look a little bit more deeper under the hood for Aurora storage. So the way Aurora storage works, it is a distributed log structured database file system, which means at any given point of time, when you issue a write to an Aurora storage, it is written to 6 locations distributed in 3 availability zones. If you compare this with multi-AZ, multi-AZ works on 2 availability zones in the same region and probably does like writes on the EBS mirror copies out there. In case of Aurora storage, you write 6 copies for every write that you do. And it's on a distributed multi-tenant storage, which means you get the benefit of having the fastest performance all the time, which is not tied to your instance size. Also, because it is a managed storage, there is its own monitoring that happens behind the scenes. So there is no management of storage to be done. And storage is automatically grown for you in chunks of 10 gig, which means you no longer have to do on your own storage scaling. With the 6 writes that it does based on 4 write columns, it also helps you to kind of address the jitter problems in latencies of disk, which means you tend to get the consistent 4 fast write performance for your databases. So this tied with the features that we give you in Amazon Aurora, the end result is you get the open source platform compatibility at the top with the enterprise-like features. And our goal is like 1/10 the cost of a typical enterprise commercial database cost, right? So you get the usefulness of the open source community database endpoints with the enterprise highly concurrent high throughput system behind the scene. Now let's talk about security on RDS. RDS follows the AWS philosophy of deploying everything with the security in mind. When we deploy Amazon RDS database instances, they are deployed in VPC. All VPCs are network isolated. We give security groups for every database deployments, which acts as your virtual firewall, which controls who can access the database and what outbound traffic of the database can you control. Like you can say you can only talk to this outbound endpoints. By using this, you can actually deploy development and production systems in the same VPC and use security groups to control accidental access, right? So for example, if you have applications that are talking to, say, a dev instance, you can use the security group to make sure that they never talk to production instances accidentally. Another thing to keep in mind is because we do everything through the AWS RDS CLI, which means we can audit all changes that are done in the database. The access to the CLI and the console is done through IAM, which allows you fine granular control on the permissions that a user has on this database instances, which means they may be able to create a database, they may be able to modify a database, they may be able to take backups. You can control whether they can create it but not delete it, so that way you can prevent accidental deletes if required. RDS also integrates with AWS KMS, which is the key management system. It's primarily used for providing encryption at rest. So for example, when you deploy an database instance with a KMS key, the EBS volumes are encrypted with the key. If you want to get the feature of using an encrypted snapshot and copy them to a different region, you can also use a custom key where you have the keys that are then transferred to the different region or even different account, and you can copy the encrypted snapshots to this region, or different region or different accounts, and then you will be able to restore it out there. Also, to kind of control unencrypted access, like especially in case of the database clients talking to the server, you can even enforce SSL for transmission between the clients and the server. We also support a lot of compliance programs. So moving on to that, we support most of the common compliance programs out there, and the compliance reports are available on AWS. If you're an AWS customer, you can also get the detailed testing reports from AWS under NDA. The common ones to highlight are HIPAA compliance, FedRAMP compliance, and also the standard SOC 123 and ISO 27001 and 9001 series. The requirements may actually vary depending on the applications using them. So you can actually work with us to see if you're eligible to be part of the compliance programs or not. With that, let's talk about like how do you monitor databases once you have deployed out there. The most common metrics that we make available are the CloudWatch metrics, which are similar to EC2 instance metrics. It gives you access to the CPU utilization, memory usage, read and write operations, and connections coming to the database. Apart from the CloudWatch metrics that are provided by default, we also have optional enhanced monitoring. Enhanced monitoring basically gives you the OS level statistics and top-like output, where you can see the top 50 processes consuming high CPU and memory. It also exposes a lot of other OS metrics, which will help you diagnose problems within your instances also. The metrics can be as frequent as 1 second intervals if you want. The metrics are available through CloudWatch, which means you can actually also integrate to CloudWatch using your third-party monitoring tools. It does have support for notification, which means you can create alarms or notifications from CloudWatch based on certain parameters. Like, so for example, a common one is if your free disk space is going down below 20%, you may want to throw a notification for somebody to look into it. One of the latest additions in the world of monitoring is RDS Performance Insights. Currently, it's available in preview for Amazon Aurora with the Postgres compatibility. Soon it will be available for all RDS engines. One of the things the RDS Performance Insight provides you is a real-time view of load happening on your database instance. If you're familiar with the CPU load on Linux, it gives you an equivalent database load on RDS Amazon instances, Amazon Aurora instances. It gives you the breakdown by top SQL statements. Within the top SQL statements, it will also give you breakdown by wait events, which would help you to say which ones are consuming CPU. By giving you that granular view of the usage, you will be able to pinpoint out cause of resource usage or contention and give you a pinpoint view on the queries that are causing them. With that information, you may be able to find problems like missing indexes or having scans that are going longer than expected, like not enough predicates to kind of narrow it down. It gives you basically view into things that were not easily visible with the open source engines before. We do expect that it will show up for all the other engines soon. With this, we would also like you to join the hundred thousands of customers that use Amazon RDS. It's very easy to use. With the free tier, you can spin up your databases very quickly, use them, get familiar with them, and start leveraging them for your business needs. With that, if you'd like to learn more, you can go to awsamazon.com/RDS. You can also go to awsamazon.com/databases to learn more about the open source databases out there. With that, I wish to thank you and open the floor for questions and answers. Thank you.